Hello and welcome back to another Cultist Astronaut video. I may sound a bit different today because I am not using my snowball microphone. My cat decided to chew the cord in half, so I ordered another one, waiting for that to arrive. It'll be here in a couple days. So for now I have to use my old Logitech headset microphone, which may sound a little worse than the snowball, but hopefully it's not too bad. Yeah, so it's been a couple days, maybe 4 or 5 days since the last video, and that is because I've been doing a lot of refactoring around our platform layer for Windows, and also refactoring the DirectX backend so that we can swap it out with another graphics API. And this is also that we could port it to different platforms easily. And the reason I'm doing all this work now is because in the future, when we port to other platforms, I want to make it as painless as possible. And if we continue to build the game the way we were, which is basically where we were just like throwing in like operating system specific functions around FIO IO and the other types of things related to the OS, like input, for example, was tied directly to Windows. And we want to avoid this because when we port it to a console or to another, desktop operating system like Linux or Mac, uh, those platforms use different functions, different code, different libraries to essentially do the same thing. So we have to do some abstractions, unfortunately. We don't live in a perfect world, so we have to do some abstractions so we could swap things in and out. So previously, the Windows function, which you see here, this is WinMain. This is the entry point for the exe. So when you run an exe on Windows, your program will start here. And it gives us a bunch of information from the operating system, like what's our instance handle, what was the previous instance. It gives us some information from about I think like this is something you can specify in properties if I'm not mistaken. So if you right click on like an exe, I believe you can actually pass these things in as parameters somewhere. I'm not sure where that's stored, but you can pass in parameters alongside your application. We don't use that stuff, right? But basically the operating system tells us to implement this function. And then when we compile the program on Windows, it will find this and link into it, and then the exe will work properly. And what we've done is we've taken this and we moved it out of our game code and into a separate script called Win32 Cultist. And basically, anytime we want to make a new platform, we'll just make a new file similar to this, and we'll change the beginning of this to like Linux underscore cultist or Mac OS underscore cultist or Xbox underscore cultist. And then we can implement the initialization for that platform in that script. And you can see here we do Windows specific things like initializing the application. Currently on Windows, we only support the DirectX 11 backend, but you can kind of see here that we're picking which renderer to use. So this is another abstraction that was made this week. We'll dive into this later in the video. And then, of course, we pass things over to DirectX like the window, which we're initializing in this function. And there is some game-specific stuff here, but it's all packed away into different functions. So we initialize our resources, which is where we're currently storing our textures. Game initialization has a bunch of initialization functions for loading our world and their entities, and basically setting it up so that the scene or the world can be simulated. We'll get into this in a bit. And then just like any game, you have a while loop which loops And this is actually pretty typical on Windows. Any Windows application will have something like this where basically you're listening to messages from the OS. And then, of course, if there is no, if it's not peaking messages or any of that, then we're updating our game. And this right here is pretty standard game logic. This right here, I'm thinking about using a different approach for calculating delta time, but this is how we're currently doing that. And for those who don't know, delta time is basically the time between frames. So we capture this, and then we pass it into our update function. And we also do the same for the editor. Right now, editor is only on Windows. This is kind of an issue if we want to run the editor on Linux or Mac. And the editor is where we create our levels and author the game data. This is for the the game designers. And so if we want to support this, we need to move it out of the Win32 layer. But this was actually just a transition. So in order to get this working, I'm putting it here for now. And then once we implement another platform, then I'm going to do another refactor so that the editor can exist above this or outside of this, similar to game. Or at least we can call these functions. This is debatable, right? We may be able to do something very, very similar to Linux, but this wasn't given much thought yet. This is just moved over here for now, and mostly because the editor depends on DirectX, because it's using IMGUI, and IMGUI is currently in our project. IMGUI is hooked up to DirectX, so it just made sense to put all this here for simplicity. So the game update, right? So you've probably noticed we have game initialization, game update, game render, and I think we even have game cleaned up. So these are functions that we can reuse across multiple platforms, right? So when we go to make the Linux platform file, we can literally call the same functions, and the game, if we did our job correctly, the game should work correctly. And basically, this is an API that we're exposing to the platform. We're saying, hey, here's some services that you can use to run the game. And these functions here, this game render, game cleanup, etc., is only game logic, right? It's platform agnostic. It doesn't know about what platform it's running on. There are a couple things we're still cleaning up, like input. So we need to move the input to the Win32 layer and basically marshal data to the game so that the game knows what buttons you're pressing. But for the most part, the game right now is agnostic to the platform, and we'll keep improving that. And the way we provide that, right, is through a header file called cultist.h. And you can see right here, these are the services that the game provides to the platform layer. And you can see the game provides resources, which are like textures. It provides game state, which is where we put all of our entities and the world data. It also provides render state, which is very specific to the renderer. So this has various buffers, and I believe it has our view matrix. And then you can see here we have the game initialization, update, render, and cleanup, right? And we also have the reverse, right? So this header is not only the glue between the platform and the game, but also we expose things from the platform to the game. So, and this is a little bit different, but for example, the platform sets this renderer backend, which we saw in the previous file, right? If I open up over here and I open up Win32, you'll see that the renderer is set right here. And this is that same variable. You can see we're using extern, which means that it's been defined elsewhere. In our case, it's been defined in the platform layer, which is Win32. And we would do the same for Linux, right? Linux would basically define this variable and then set it to like OpenGL, for example. So you would have like in Linux it would look like this. Or perhaps it's Vulkan, right? Depends on what we decide to make. So that's how that works. And the reason why it's here is because the game needs access to this renderer backend. And we're going to dive into that in a bit. But first I want to continue on with the game specific code, right? So the game is in the cultist CPP file. So you can see a pattern here, right? We have win32 cultist, right? We have cultist.cpp and we have cultist.h. And in the future we'll have Linux cultist, Mac OS, etc. And that's why we call this cultist.h, is because it's shared between cultist CPP and the platform specific cultist. That's a lot of cultists. Yeah, let's look at the game code. So in here, this is where we actually implement our various functions for game update, game render, etc. And like I mentioned, these are very specific to the game logic. And so it shouldn't know about DirectX or Windows at all, right? And you can see we've done a fairly good job of doing that, right? I mean, there's a couple things here that we might need to reconsider, especially around file I/O. Like loading a file onto Windows is likely to be different than, Linux or, some console like Xbox. So we want to make sure that we move that up to the platform layer. But for the most part, everything here is game specific. And we can provide this function to Linux, etc. Now let's talk a bit about the renderer backend. So how is this utilized? Well, if you look at the game initialization down here, you'll see we're calling things like create texture array and create sampler. This is the texture sampler, by the way. And we create these things specifically when we're loading the game. And they're specific enough to the game that we want them to be here and not in the DirectX layer. And so you can imagine like we're loading in like 3D models or textures that are specific to the game. We want to be able to create these resources in the game code. And then we want to swap the backend out so that it can figure out if it's creating these resources on DirectX or creating them on OpenGL. And that's what this render backend facilitates. So if we go to, well, we have a couple files to look at. If we go to renderer.h, which is where we define the renderer backend, you'll see it's actually a bunch of function pointers. And the function pointers allow us to set these to functions that are specific to each backend. So DirectX implements a load texture, a texture view, texture array, and it implements all, I guess this is 11 functions. And this will continue to grow, right? We'll continue to add more functionality as we need it, but these are currently the functions we're using to initialize and render our game. And then, of course, we have render state, which I separated out because it's state that is, well, it's purely state, right? It's not behavioral, so I wanted to put that into its own thing. And then if for whatever reason we decide to like switch the rendering backend on the fly, we know that we need to update the render state. And I think the big reason why I separated these two is because if you go to like DirectX 11 and you jump to the bottom of this file, you'll see that we actually create a rendering backend called dx11, and we set these basically statically. Like this is a static variable that basically lays out all the functions we need. And you can see we're not setting we're not setting any state here, right? And so I wanted to make a separation because this is static, and what you see in renderer.h is actually initialized at runtime. So this is like static function pointers, and then this is basically data that we create when we launch the game, or when we're loading the game, I should say. So yeah, if we go back to DirectX 11, you'll see that we have all of these functions defined here, and they're essentially wrapper functions around the specifics of, releasing a buffer, releasing a texture sampler. And the same thing up here, we have all the creation functions, which are very specific to DirectX. So you'll see we create like a texture 2D description, we populate that, we create the texture 2D, and we have functions exposed that make it easy for the game code to do this. And if we go back to renderer.h, you'll see that these functions don't know anything about DirectX. You'll see we're actually making use of void pointers, which sounds scary, but they're just memory addresses. It's like this is a place in memory where we're storing this resource. And then in DirectX 11, when we read this in, you can see there's still void pointers here. But then when we make use of them, we cast them to the specific type. Now there are different ways to handle this type of abstraction. This is the way I chose to do it because it gives me flexibility in swapping the backends. And I have complete control over those pointers. It's very similar to what you would do with like a virtual function, except that I have a lot more flexibility in how I assign functions to those pointers, right? And then, of course, like I've already mentioned, we set this up at the start in the Windows layer. And then, of course, in Linux, we would change it out. And then the game code would work like normal, right? The game code being in cultist CPP, right? All these things we're doing here where we release the sampler, release the vertex buffer, or we create, a sampler, these things would call into their respective renderers. So if we're running Vulkan on Linux, then we'll call the Vulkan version of this. Now, I actually haven't implemented those APIs yet. I'm getting ready to. In fact, I need to start looking into OpenGL and possibly into DirectX 12. I kind of wish I did DirectX 12 originally, but there might actually be a benefit to having both DirectX 11 and DirectX 12 because some machines, like some older machines, only run DirectX 11 and not 12. But I digress. These are things that we can now do, right? And hopefully we've simplified it. Now you may be wondering, why are you doing like all of this work? Why not just use some, library that does this for you? Well, I looked through a lot of the libraries and they are fairly complex and they do everything you can imagine from, a 3D rendering API. And so one, I felt like it was overkill to go down that route and basically incorporate a bunch of complexity from someone else's API that tries to do it all. But also, I really want to learn these things from the ground up, and if I use something that does it for me and does everything for me, then I'm learning that API and I'm not actually learning how to interact with DirectX or OpenGL. To follow that point, I'm also not learning how to optimize for DirectX or for OpenGL. Whereas these libraries that try to be everything and do everything, they try to cut corners so that they can do that. And as a result, you end up with a less performant version, right? And not to say that I'm obsessed with performance. Like if we can get the game running and it's reasonable and it's not laggy and it's not buggy, then we've done our job, right? And I believe you can do that with these APIs. I still want to learn it and I still want to have control over my program, and I want to have something that is hopefully simpler. And even if this does seem a little complex on screen, like what I'm doing, it is much simpler than what I've seen. So yeah, that's been my experience this week. I'm still learning a lot about how all of this is coming together, but I think it's going well. And hopefully soon we'll have this running on a different platform, and we'll start getting back into the gameplay side, which the big thing on my plate for that is to implement and port over all of the AI logic for our enemies. But yeah, that's my update for today. I hope you have a wonderful day. And as always, leave feedback, comments, and yeah, see you next time.